Good morning, everyone. My name is Dongmei Zhi from Institute of Automation, Chinese Academy of Sciences. It's my pleasure to introduce our work, NR4A1, Associated Multimodal Neuroimaging Patterns, Impaired in Mesial Temporal Lobe Epilepsy. Epilepsy is a prevalent and devastating neurological disorder characterized by recurrent unprovoked epileptic seizure, affecting 0.6 to 1.5% of the population worldwide. Mesial temporal lobe epilepsy is the most common type of focal epilepsy, and seizures are often resistant to anti-epileptic drugs, even in benign cases. While there may be many causes leading to MTLE, a growing number of studies have identified that DNA methylation plays a critical role in MTLE patients, and previous studies have identified that more than 70% DNA are hypermethylation in MTLE patients. Among all DNG, 1G, NR4A1 has higher expression levels in MTLE patients. And it has been identified that methylation level on NR4A1 in MTLE patients were correlated with its G expression levels. More importantly, it has been reported that NR4A1 knockdown can alleviate seizure severity and prolong ascent latency of temporal lobe epilepsy in mouse models. Numerous studies have reported both functional and structural abnormalities in MTLE patients. For instance, it is consistently reported that MTLE patients should reduce gray matter volume in elements, aberrant functional connectivity in default mode network, and altered fractional anisotropy in corpus callosum, acid fasciculars, inferior longitudinal fasciculars, and in superior longitudinal fasciculars. And epigenetic abnormalities are responsible for both functional and structural reorganization, which may contribute to the formation of hyperexcitable circuits and seizure activity. Therefore, we hypothesize that aberrant NR4A1 methylation may be related with altered functional and structural networks, which may lead to impaired cognitive and executive function in MTLE patients. Shi and Jinshui proposed a method, multi-site canonical correlation with reference, called MCAR. This method can leverage the cross-information among multimodal neuroimaging data to reveal important relationships that are specifically related to the matter of interest, which cannot be detected by a single modality. And this method has been successfully applied to major depressive disorder and schizophrenia. Here is a flowchart of the supervised three-way multimodal fusion method. Methylation level of NR4A1 were used as a reference to guide the fusion of functional connectivity computed based on the Brainstorm Atlas from fMRI, fractional anisotropy from DMI, and gray matter volume from SMI, that enable robust extraction of targeted neuroimaging markers that were correlated with the methylation level of NR4A1. The table shows the demographic and clinical information of participants. Our study included 56 MTLE patients and 65 age and gender matched health controls from Xianyang Hospital Central Science University. Due to the difficulty of procuring methylation level of NR4A1 from the brain tissues, here we used the methylation level of NR4A1 from the whole blood, and it has been reported that methylation level of NR4A1 in blood can serve as a surrogate for the brain. And the results suggested that methylation level of NR4A1 in MTLE patients were significantly higher than those in healthy controls. One joint component was found to not only show significant group difference between MTLE patients and healthy controls in all three modalities, but also show significant correlation with methylation level of NR4A1. For multimodal querying patterns, Results showed that MTLE patients showed reduced gray matter volume in thalamus and putamen, lower FA in phonics, and aberrant functional connectivity among putamen, thalamus, and globus pallidus. And aberrant temporal network activities were also found in MTLE patients, including reduced gray matter volume in inferior and middle temporal gyrus and temporal pole, and aberrant functional connectivity between temporal lobe and inferior parietal lobe and cerebellum. Rats also exhibited reduced gray matter volume in cerebellum, lower FA in cerebellar pedicles, and aberrant functional connectivity between cerebellum and middle temporal lobe and occipital lobe. In addition, the identified joint component associated with methylation level on NR4A1 were also correlated with age and onset of MTLE patients, suggesting that higher methylation level on NR4A1 were correlated with more severe epilepsy. They are also correlated with minimum mental state examination scores and healing sentence complete test scores, suggesting impaired cognitive and executive function in MTLE patients. In conclusion, this is the first study to link the methylation level of NR4A1 with multimodal neuroimaging data in MTLE patients. Results showed that higher methylation level of NR4A1 in MTLE patients may affect both brain function and structure in subcortical nuclei, especially in putamen and thalamus, and temporal network, especially in temporal pole and cerebellum. They are all commonly impaired in functional connectivity, fractional anisotropy, and gray matter volume. The identified brain regions were also correlated with age and onset of MTLE patients, their MMSE scores, and HSCT scores, suggesting increasing methylation level of NR4A1 may be linked with early MTLE onset, as well as more impaired cognitive and executive function in MTLE patients. And these results implicate a potential imaging methylation pathway modulated by methylation level of NR4A1, which may affect MTLE patients. Finally, I'd like to thank the guidance and massive efforts from my advisor Jin Shui and other colleagues and partners. And further information is available in the poster number 2560. And below are some related poster works. If you have any questions, you can also email to me. Thank you for your attention.